Hey everyone, and welcome to another exciting installment of the CS Skills Exchange. Today is going to be an abbreviated session since we're going to be ending at the top of the hour for the Michael McBride's AMA. But today we're going to be talking about how to implement DataOps using GitLab. And we have Emilie Schario here to give us an overview and answer any of your burning questions. So without further ado, Emilie.
Thanks, Chris. Hey, folks, my name's Emilie Schario. I've been at GitLab for almost 2 years now. I was the first data analyst at GitLab, moved into a data engineering role, and now I'm on the chief of staff team as an internal strategy consultant. Chris put together an awesome issue, which links to the video of a talk I gave at GitLab Commit in San Francisco. I'm not going to give that talk here, but I want to share the general ideas behind that talk. Right. So the first thing is, what is DataOps? We all know what the DevOps figure 8 is, right? I don't need to explain this piece to you, but DataOps builds on top of this. Let me switch marker colors so that you can see a little better. So DataOps is about applying the principles of that we've seen be effective in DevOps to data. And the key difference is that data comes in to this, you treat it, you develop in it the way you would DevOps, or the way you would build a software application. And then what comes out is your analysis, right? So this goes kind of vertical through the DevOps figure 8 and then actually funnels back. I'm going to switch marker colors again. There are what I call 3 tiers of data analysis. The bottom is reporting. These are what I call facts. Reporting is like how many new users signed up on our website, or how many pipelines were run last month. It's very like fact-based questions. You get the information. Then the next level is what I call insights. Insights are where you combine 2 pieces of information from different data sources so that you actually provide business value. So in a really practical example around your work at GitLab, you might be interested to know, like, what stages of the product do people use in order to indicate that they're going to keep using the product a year from now. Sorry, let me quit Slack. So that's insight, 2 data sources combining to give you valuable information. And then the final piece, the top of the pyramid, is what I call predictions. We're not talking about fancy machine learning models or anything like that. It's just saying, okay, based on X and Y, where do we expect to be 12 months from now? And most data teams are still stuck in this bottom square right here, reporting. That's because they spend a lot of their time building analyses to answer simple fact-based questions that when something in their data model changes, break. And so they spend all their time maintaining here. They never get to move up the stack. So the big problems data teams have are data integrity, data quality, and data reliability. And DataOps is the way to kind of combat that. So that's the short version. I'm going to jump a ton more links in that issue. But I'll dive into the questions now. So DT, you've got the first question. Is DT here? Maybe not. So DT asks, how often does this topic actually come up with prospects? For him, it's been once in 3 years. I get pulled into a call probably 2 or 3 times a month. And part of the reason I'm on this is because I can't keep getting pulled into calls 2 or 3 times a month. And so we're looking to kind of really empower you all with the information you need to confidently have these calls. Any other questions?
Looks like a couple people are thinking.
I think it'd be easier just to ask here rather than type it in. So
yeah,
looking at our pipelines now for the data team, and looking at, we're using Snowflake for, it sounds like, warehouse, extracting dbt for transformations. Is this a common flow for DataOps teams to follow for continuous integration?
Yeah, great question. So there's one thing I'll start by answering, and that's by saying there are 2 general approaches to data movement. The first, you may have heard of this, is ETL, right? Extract, transform, load. And depending on who you're talking to, this is going to be the norm they talk about. This is a kind of an older way of working, and the norm today is ELT, extract, load, and transform. And the reason for that is because your business logic will change, right? So let's think of a practical example. We're an e-commerce company and we have a website, and we might say that a new user is someone who has never visited our website before, period. And over time, as you get more data on your users, you're going to be able to connect their cell phone visits and their computer visits. And then also if they have I don't know if you can see, there's a laptop right there, right? That's my personal laptop. It's right there. That's my personal laptop. And so as you collect even more data, you're going to want to be able to see someone who connects from their work laptop and their personal laptop and their iPad or multiple cell phones and all that kind of stuff. And so your definition of new user will evolve as you get additional information. So the appeal of the ELT approach is that when your business logic changes, you don't need to move all your data again because it's already stored in your data warehouse. There are 3 major data warehouses on the market: Snowflake, BigQuery, and Redshift. BigQuery being Google, Redshift being Amazon. Those are definitely the 3 most players. I've seen them cover probably 85% of the conversations I've had, with an asterisk being that a big part of what's left is teams that are using Postgres for analytical purposes. That's okay to get started with. It won't scale as well as an analytical data warehouse, but it's a great place for teams that kind of already know Postgres technology. In terms of, is that whole stack standard? The first thing I'm going to do is I'm going to share my screen with a graphic on what that stack is, so that, oh, actually I have it in these slides. I'm going to share the screen. Okay, so data comes from wherever and it gets loaded into your database, and then you do things to it, and then it's ready for consumption. And then your consumption is held by a BI tool or a Jupyter notebook. So at GitLab, data comes from a myriad of sources like Salesforce and Zuora and product usage and stuff like that. It gets loaded into Snowflake. So everything in this section happens in Snowflake. And then our BI tool is Sisense. This is a pretty standard structure for a lot of data teams, where machine learning, data science happens here, but this middle part is pretty similar. dbt, which is what this logo is kind of the premier open source tool that does this. There are a couple others. Dataform is a paid one. Matillion is another. People have homegrown versions of this, but dbt is growing in popularity. They've been around for 4 years. They have several thousand weekly active projects nowadays, and are increasingly the default tool when it comes to this stuff. Does that answer your question, Joe?
That does, thank you.
Cool.
Hi, Emily. I have a question. Based on the diagram you just showed, can you illustrate or highlight where do merge requests, or how does GitLab factor specifically into that diagram?
Yeah, great question. So, okay, I'm thinking about how to answer it. Okay, so data comes into the data warehouse, and you don't store your data in your repo, but the processes that you do on your data are stored in the repo. So all of kind of this orange and blue sections here happen in SCM. Let's look at what that looks like. GitLab.com/GitLab-data/analytics. So transform, dbt. So this is kind of GitLab's dbt project. By the way, this project is public, and on the sales calls that I've been on, they've found it really useful to point customers to this after calls. So take note of this this link, but this is our DBT project, which has multiple parts to it. Models are kind of the core part of what DBT does, and you'll see that all of these models, I'm thinking of a good example. So this is our, let's use Salesforce because it's a pretty canonical example. So Salesforce opportunities, SFTC opportunity. This is the model that underlies the Salesforce opportunity analysis. So, you know, we take things from the opportunity table, we do some cleaning and renaming and clean some stuff up. Like, this is our transformation. So if we look back, this is the transformation that's being stored in SCM. Our DBT testing is also stored in SCM. So if we go back to our DBT project, we go to tests here, same thing. We could find tests. You'll see snapshots, documentation. So DBT ships with really great documentation. We host ours on GitLab pages. It's dbt.gitlabdata.com. And you can kind of see everything that's going on here. It takes a second to load because it's JavaScript. But then we could go see that same Salesforce model that I just showed you, SFTC opportunity right there. And it's documentation around the columns and what they are and what's going on here. And you can see kind of the DAG. So this is why DBT is really great. In terms of where all of like the rest of GitLab outside of SCM fits in. So Plan, the GitLab data team uses Plan just like the engineering teams would. CI is a really great way for teams to get started. So when we use merge requests, because we are making changes against those things that we just saw, we use a process leveraging one of the Snowflake features called zero copy clones, where they make a clone of the production environment. Think of this as a dev environment, which, and that's created whenever a merge request is created. It's, I can link you to the GitLab CI script. But that allows the merge request to run in a clone of production. And that way we can see the data after like the new changes and make sure and compare its state in the merge request to production to kind of see what the side effects are. So that's one way we use CI. The other thing is that some teams use CI pipelines for actually running their DBT deployments. It's hard when you have like a large DBT deployment. So when I started at GitLab, the data team was 3 people. Then we were able to use GitLab CI to manage our deployments, and that was really great. As your deployment gets bigger and your dependency graph, or it's called a DAG, a directed acyclical graph, when it looks like this is only things related to Salesforce opportunities. If we were to look at everything, this graph were to update, you can see how big, and there you go. So it's big and complicated, and there's a lot of different slices to this. And so we use Airflow, which is the canonical tool here, but we host Airflow using GitLab. And I'm happy to link you to the docs on that. Does that answer your question, Kurt?
Yeah, it does. I think you know, the question I get, or at least recently got, is like, how does GitLab do data science? And that's like such a broad topic, right? And so for me, my thing is like how to filter them down to whether that's that like triangle graph you showed, like, are you doing reporting? Are you doing analysis? Are you doing something more advanced than that? I think we could probably go really deep on that diagram you had of like, well, you could use a merge request here and you can use incidents here, like trying to fill that diagram with as many Tanuki logos pointing at like how GitLab can fit into your data science pipeline. Like that's the story I'm trying to tell.
Yeah.
So I think that gives a high level. I think, you know, data science is new to me and probably new to a lot of other people. So there's still some concepts I'm trying to grok, and some of the like the tools and the logos that I'm trying to understand, like what they do and why one is better than the other. But yeah, it does. I think it's this is like probably not the best enablement session to cut short, because I think we could probably go super deep on some of this stuff, but at least it's a good starting point. So yeah, thank you for that.
Yeah, so two things that jump out to me from that question. One, see if you can push to understand what they mean when they say data science. It's a really ambiguous term. Some people use it to mean data analytics. Like for example, at Lyft and Stitch Fix, two very well-known companies in the data space, they say data science, and that includes data analytics, just like simple, straightforward reporting. That's really different from how we use the term, how I even use the term. I don't think data science is an umbrella term. I think data is an umbrella term and data science is a subset of that. But you know, everyone has their own language. So one, push to see if you can get a better answer around what they're doing. Do they mean analysis? Do they mean data engineering, which is the movement of data? Do they mean machine learning? Do they mean advanced statistical methods, which is what I would actually mean by data science? So understanding kind of more of like, what do you mean when you say data science is going to be the better way to figure out how to push the conversation. Because if the answer is advanced statistical methods, what they mean is Jupyter Notebooks. I'm not a fan of Jupyter Notebooks, and so like unless that's what you're looking for, you probably shouldn't recommend that. But GitLab does a lot to make that part easy. So that's number one. And then number two, I'll work with Chris to get another session on the calendar in the future.
Yeah, absolutely. And please, just a shameless plug, fill in those issues with comments, questions. As the more information you all give us, the more we can be detailed and do deep dives where it's, you know, most beneficial.
Joe, I see you typing.
Today, but happy to dive deep in any of these different topics that we've touched on today.
Joe, I'm getting you that link right now. Give me 1 second. Oh, actually, while I'm doing that, let me share my screen. So people, here is, like, this is a data infrastructure page. I'll drop it into the doc next, but you can see here what our diagram for our data structure looks like. There are a number of third-party data sources, right? Zuora, Zendesk, Salesforce, NetSuite, we've all heard of these. We use off-the-shelf ETL tools such as Stitch and Fivetran to move the data into our Snowflake data warehouse. So that's what this big box is. And then we do those transformations we talked about. See those little DBT logos there? And that triggers kind of what's ready for analysis. And then people write queries in Sisense that happen on Snowflake. So this is a really short version. All of the orchestration that happens here happens with Airflow. So I will drop this link in the chat, but that's a good place to start.
So I'm in a conversation right now with the DataOps team, and they were asking, where does GitLab work with Airflow? It sounds like you're saying GitLab can host Airflow, you're saying? Like through a Kubernetes cluster, or?
Yeah. Oh, I just muted myself accidentally. Sorry. We use a GitLab hosted Kubernetes cluster for that. And one of the cool things about the data team project, like I said, is that it's all public. So gitlab.com/gitlab-data is a great way to not just say, here's what our data team is doing, but also like, here's the code that we're using to run this. And it's a really great way to point people where they can kind of not just read the handbook and documentation, but like, here's the exact code for how we run our pipelines, and here's what our graphs look like and stuff like that. So awesome. in that project, you'll see our Airflow image, like for the Docker image, and then the orchestration piece. But I just dropped the link to this data infrastructure page, and that should point you to all the right places. Thanks. All right, we've got 3 minutes left.
So an ad hoc question, which might be naive, but I was thinking there is this whole ETL which we're running in GitLab, and that determines what is the target schema to which you process the raw data. Every time you change it, would you rerun those transformations for all the data, including the historical data? How long would that take? What is the performance implications of doing this?
That's a great question. If I'm understanding correctly, you're saying like, okay, data lands here, and then we want data to be ready here, and it goes through some transformation process, and every time we get new data, do we rerun all this new transformation? That's the question, right?
Yeah, that's the question.
Yeah, so the answer is, it depends on the volume of data. So for some volumes of data where it's small, like data sources, not GitLab.com, for example, like smaller data sources, then yes, we rerun everything every time because they're stored as views, and what that is in a database is maybe not relevant, but it's not a performance hit, and it's actually better to just run the whole thing in terms of performance. Where we're talking about like quantities of data, we only transform that new slice. We only transform that new slice. And so what we have, and what dbt is smart enough to know, is that like, oh, only this bit is new, let's only transform that bit. And it just kind of appends to the bottom of the existing table.
Okay.
Does that make sense?
That. Yeah, absolutely.
Yeah, so we call this incremental materializations.
Cool. Interesting. Let me put note on this one. And by the way, I like the way you're doing the drawings on that pad. I need to adopt that for my presentations.
Thank you. I think it's easier if we're all looking at the same thing. So.
Absolutely. It's a splendid idea.
What a novel concept.
Right? Yeah, in a technology company. It's such a low-tech thing, but it works. Splendid.
For the record, there's also another whiteboard all the way over there, but you can't see it. So I just have the little handheld one for calls. But cool. So we've got a minute left. Oh, it looks like there's more demand. So we'll definitely work on getting something scheduled for the future. Does anyone have like a final question they want to get out?
So if you were to talk to customers, they're on the verge of the starting data science, what's the one thing in GitLab you recommend they start with?
Yeah, so there's like two parts to answer this question. It's actually a super complicated question, because if they're saying like, hey, we're getting started with data science, my first thing is like, do you already have a data analytics organization, or are you actually getting started with a data analytics organization? Because if that's the case, then my answer to them is going to be they need to start with source controlling their transformations. Just getting started with Git. And so for a long time, a data analyst was someone who was really good at Excel. And nowadays, a data analyst is someone who's really good at code. So that's where I would start. If the answer is no, they really want to get started with data science, they are not worried about analytics right now, I would focus on the ways they can leverage GitLab and Jupyter notebooks together to build analyses, build kind of statistical, the data science output that they're looking for, and version control it so that they understand what changes are happening over time. I've been on calls before, I'm almost embarrassed to admit this out loud, but I've been on calls before where people's case of version control was like screenshotting the code. And that's like common in data science. Yeah, those faces, that's how I felt. That is like, just getting started with version control is where most people need to start. Like data scientists, machine learning engineers, a lot of times they're coming from academia where business best practices like version control is still a foreign concept. So we need to spend time educating on that need to really help them think about how to grow and scale and create reproducible analyses for their org. So in the same way you think of selling to like developers with, you don't have to convince them of version control in the same way. You need to teach what version control is and convince them that they need version control to have a successful data team.
Excellent, thank you, I love that answer.
Yeah, cool. Well, we're over time. Thanks so much, folks. I really enjoyed chatting with you all today.
Thank you so much, Emily, for
Thanks,
coming
Emily.
and chatting with us. Thanks for all the
Emily.
great questions. So I'll get with Emily, and if you have thoughts on future sessions around data science, please send them our way, and we will be happy to get another session scheduled. See you all in the AMA shortly.
Bye.